you, this is the third time we've met. It's the fourth time. Brianna. Yeah, I'm still looking at the cheat sheet here. Maddie. Oh, Andre. Zoe. Kiki. Hunter, I assume. Gabby. Not that it's required, but I do appreciate people sitting where they usually sit. Jasmine. Jesse. There we go. Becca. Jesse. You're out here somewhere. There we go. All right, so Nathan. Today. And not seeing Aisha either. I'll start out with any questions. And by the way, that's gonna make a great YouTube video of my doing wrong. It's exciting as ASMR. Are there any questions?
Yes, how come no one told us that we should, make sure that we take care of chapters in your class, cause it's going to help us in lab class on Thursdays?
We wanted to surprise you. Yeah, I mean, the people who do when you're doing the lab, it's not necessarily completely in sync with the class, so that.
No? Okay, hold on a second, mister.
Nathan?
Yes, sir.
All right. While Latoya's out, any other questions? All right, I got one. What was the last thing that we did 2 weeks ago?
It was the graphs, where we would X out the certain ones.
Ah, okay.
Yeah.
And
We
we,
did the-
it just set up for the long problem, or
We
did
already
that?
did that one.
We did the long problem?
Yes. Where,
We usually, the problem I do after that.
yeah, we did that one.
Okay, so that's not the last thing we did.
No, we did the ball is dropped in the earth where it goes, like, goes across and out.
Okay, not the drop, it's sliding.
Yeah,
Okay, we did that already.
yes.
All right. So since we've done the test level problem, let's get into the math side, because I know you're all dying to see some math. So let's just start out with some math definitions. All right, so first off, just symbol recognition. Some students are still struggling with this. What is this a symbol for? All right, louder, please.
Velocity.
There we go, thank you. Suppose it's just, I don't need the AVG right now. Suppose it's just a plain old V?
Speed.
Yep. All right, so our average velocity is displacement over time. Sorry, spoiler alert there. What is the stop symbol? Or let's just ignore the delta for a moment. What does X represent?
Position.
Yes, and with the delta in front,
Displacement.
that works, or,
Displacement.
yeah, either one. Displacement is change in position. Over time, now I don't say change in time out of habit, it is just however much time took place. And acceleration, since we'll primarily be dealing with constant acceleration, I guess technically it is average change in velocity over change in time. So let's just start out with a simple example of a ball. Starts at rest. And accelerates uniformly for at 3 meters per second for 5 seconds. After those 5 seconds, what is its velocity? What is its displacement?
Is
Yes.
the phone recording? I don't see the red button.
Oh. Yep,
Oh,
if you saw the red dot there, that means it's not recording, but there's a red dot blinking down here.
okay.
We're good, thank you though. It would not have been the first time I not recorded. All right, so we're starting out with, we have an, there's a mistake up there. It's a simple correction, so it's not like you have to erase much or anything. But acceleration units would be meters per second squared. So we're going to find the velocity. We're going to answer the first one 2 different ways, potentially 3 different ways. But we'll just start out with the straight up math bit of it. I'm just going to use this equation right here because we know acceleration, we know time, and we're trying to figure out what the velocity is. So first off, change. Change in velocity, what am I subtracting from what?
It would be the final minus the initial.
Yes. Change is always the final whatever minus the initial whatever. So I know my acceleration is 3 meters per second squared. I'm going to put in units for right now, and then I'm going to sort of drop units so that we can see what the math problem is. That's equal to my final velocity minus my initial velocity, which, what is my initial velocity?
Zero.
Why?
says so, no problem.
What's the key word here?
Uh,
I don't explicitly say the initial velocity is 0.
Rest?
Yes, that's the key word. So when you see this starts, so it should be at rest. But rest is the code word, meaning it's not moving. Minus 0, divided by the amount of time, which is 5 seconds. I guess that's 0 meters per second. So that's plugging in with units. Again, wide variety of math abilities in the typical 110 class, from people who shake at the thought of actually doing any math, to those who occasionally I've had some who've had calculus. That's a rarity, but it happens. So the math problem is I have 3 is equal to v minus 0 over 5. That's the math problem right there. The units and the symbol for vector, that's sort of trappings of physics. So I'll start out with the simple part. What's v minus 0?
0.
V minus 0.
Well, true. I would agree that it is true, but let's narrow it down a little bit better than that.
V.
I think you just said it.
V.
V, yes. And anything minus 0 is just whatever it was. Thank you.
I don't think it helped, but I tried.
Yeah, the door's locked, so
Oh, is it?
she'll
Oh,
knock when she needs to come back in.
Never mind.
That's,
You wanna crack it? Or,
have a seat, she'll knock.
okay, I didn't know.
Or we'll hear her get to the door handle. All right, so this is just, so I have 3 is equal to v divided by 5. And so now the question is, how do you solve this? Some of you can do it in your sleep, and some of you, again, if it's a typical class, look at that and think, wait a second, I've seen something like that sometime in my lifetime, but. There we go. So from one point of view, it's what divided by 5 gets you 3, or you could look at this as 3 divided by 1 is equal to v over 5 and cross multiply. Or I have 3 is equal to v divided by 5, and I multiply both sides by 5. 5's cancel out, I'm left with v on the right, and then 15 on the left. However you need to look at it, the answer is 15. So my final velocity now, if you write that, I'm going to take off for that answer. Why would I take off for that answer? Absolutely. And what should they be?
Meters per second squared.
Take 2.
It would just be meters per second, right?
Yes, yes. The squared, it goes with acceleration, meters per second. Think if you're going down the highway, you generally go in miles per hour. It's some distance over time, just one time. So if you're comfortable enough with the math, that's ultimately a faster way of doing it. But any questions on this before we do the exact same problem except a different way? All right, so I'm going to set up a little chart here, time and velocity. That's in meters per second, that's in seconds, and 0, 1, 2, 3. Now, I know what the answer is going to be at the end, but we'll get there. All right, so what this acceleration means here, that 3 meters per second squared, that's just 3 meters per second. In other words, my velocity changes by 3 meters per second every second. So after 1 second, well, it's changing by 3. So it's 3. After the next second,
Six,
you're on a roll.
9, 12, 16. I'm kidding. 15.
Now, the nice thing about this type problem is we could solve it two different ways. If we got two different answers, so let's just say that, for example, he wasn't joking, and he got 16, but he got 15 the first time, that's one of those points where you go, wait a second, something's off. And if you have time, you investigate it. So the second way of solving the exact same problem, it's, it's fine for if I've got a 5-second problem here, but there was one test where I made it 41 seconds, just because I wanted people to do it the other way. I didn't ban this from doing it this way, and somebody actually went through and they did all 41 of them, or actually 42, because there's a 0 there. All right, questions about the V final is equal to 15 meters per second? And I know two of you missed most of it, so if you have any questions.
This, I was gonna say, I was reading the book and it was kind of talking about, this specific, problem right here. So, I think I kind of got, you can kind of go over it to talk about what you were talking about to make sure I got the gist of it. But what I'm understanding is, if you're gonna, I guess the time is, what's that, 5 seconds right there?
Yeah, that's 5 seconds.
5 seconds right there, so, as you got the 15, I guess every 5, I don't know the correct pronunciation.
Okay.
But, every level of 5, is it 3 times, every level of 5, it went up 5, and that's how you got to the 15? So if it was going to 0 to, I guess, 100 and some odd second, or 5 seconds, it would go like, I guess, like 20, no, like 20, 60, 100, yeah, you got me?
Yeah, I believe so. I mean, if this had been
I hope so.
100 seconds, then we would just 100 times 3.
Right,
Yeah.
okay.
Now, the way Hewitt has it listed in the book, he does a problem similar to this where he's dropping an object. And it's how fast is it going after 10 seconds or 8 seconds or whatever it happens to be.
Boom, so that's what I was talking about right there.
Okay, it is very similar to that. The difference between that problem and this problem is in that problem, he doesn't tell you this. Because in that problem, if I drop it, it's what the acceleration is generally known for a particular location. So for example, Earth, that acceleration,
0.8 meters squared.
No, just meters per
Meter.
second.
Per second squared.
there we go.
Sorry, yeah.
So that is the acceleration. Notice I don't have a vector symbol over it because if I did put a vector symbol over it, I need to indicate direction. What is the direction of the acceleration due to gravity? I saw one person make the gesture. I think 2. Yep. See if we can get a third person. Oh, yep.
Keep it going down.
There we go. And out loud. So the acceleration due to gravity, 9.8 meters per second squared down. Now, whether that's positive or negative depends upon you. It's when you're doing a problem, you get to decide what the positive and negative direction are, and something like that. I do want to point out, though, that a symbol that is often used for acceleration due to gravity is the lowercase g. This does not stand for gravity. This stands for acceleration due to gravity. The distinction is there's going to be 3 different things that we talk about in this course that, unfortunately, I see more in 110 than the other classes, although they're not immune from it either. There are 3 things that students will tend to call gravity, and they're all very different. There's the acceleration due to gravity, there's the force due to gravity, and then there's the gravitational constant. They are all very different. They're all related to gravity, but they are all very different. So this is G stands for the acceleration due to gravity. That's 9.8 meters per second squared. Acceleration due to gravity is a scalar, so there's no direction involved. It's always a positive number. So that's G for Earth, but approximately. And again for Winston-Salem. And it varies depending on where you are. But at this point, the whole world's been mapped at this point. Somewhere, if you can decipher the text file of numbers, you can figure out what the acceleration of gravity is at that specific location. All right. Questions before we start to tackle the displacement question? All right, so before we can actually answer what is the displacement, another question is, what is the average velocity? Because if I know average velocity, I know time, I can find displacement, doing the exact same kind of math here. But how would I find average velocity? Well, how do you average numbers?
Add them up and divide by how many ever you have.
All right, go for it.